Okay, welcome to Accelerated Math. This is a long objective name. It's determine a length using intersecting chords, two secants that intersect outside a circle, or a tangent and a secant that intersect outside a circle. Whew, that's a mouthful. But bottom line is there are a lot of different types of problems on this one, so look for your example that you need to review and see if you can figure it out based on the discussion here. Alright, so I'm going to start with this example, and this is one of the simplest ones. There's basically two chords that are intersecting. They said, intersecting chords. And they've given us some lengths. So this one's 14, 12, 28, and I don't know, but I want to know. They want us to find the value of x. So here's what we're going to do. Some people call this one a part times part equals part times part, and I'm okay with that. What they're saying is 14 times 12 is equal to 28 times x. And it's pretty simple after that. What's that? 144 and another 172, I think. I don't know, that doesn't sound right. Yes, 172. Alright, 172 equals 28x, and we're dividing by 28 on both sides to solve for x. The 28's cancel out or become 1, so I got x equals, I believe that comes out to 6. Alright, so that's one way to do it. Part times part equals part times part. I kind of like, I don't know, this method works for me. It's real easy. The way it's arranged, I'm just going to create a proportion. And you're going to say, well, it ends in the same thing. And then you solve that proportion. When you have a proportion or two ratios that are equal to each other, the little shortcut to solve for one of the unknowns is to cross multiply. So you get 14 times 12 equals 28 times x. Why do I like this? I don't know. You see this other circle? I just put it in here, and I put my proportion in there. They're asking for Vx. This side right here, they have that x in there, but they were asking for the segment length of Vx. So I like it. You can put those in there, the little fraction things, and create a proportion out of it. 5 times 14 equals 15 times x. 5 times 14 is 70. And 15x, we're going to divide by 15, and we get x equals, let's see, it would go 5 times this, so it's about 4 point something, so, I'm going to say 4.7. I do believe that's correct. Alright, and that's it. So like I said, those are not too bad. Again, just remember part times part equals part times part, or put in the little proportion things and cross multiply, and you're going to get the same thing. Alright, moving right along. We got this circle with two secant lines that are going through it. Secant lines are lines that go through the circle and continue through it through 2 points. And they're giving us some information here. DH equals 27. So I'm going to label what DH is. D is this point right here where these two lines intersect, and here's H. So all the way from here to here is 27. They also labeled G for us. They put a 7 there. And they want to know the length of DE. So I'm going to put an X here for this one. And did they give us anything else? Oh, DF. Sorry, I mentioned DF is this whole thing from here to here. That is 23. Now, if the other one, the two intersecting chords, was remembered as part times part equals part times part, the little catchphrase from this one is ow equals ow. And I'll explain that. That's outside times whole equals outside times whole. You got it. Now let's look at what we're talking about there. The outside is just this little segment. Let me get my highlighter here. This is considered the outside, and that's considered the outside. It's the little segment that's on the outside. The whole is considered the whole length and the whole length. Okay, so we're going to just work that. So I'm starting up here at the top here. I've got outside 7 times 27, the whole, equals outside the 23 wait a minute, outside, I'm sorry, the outside is outside the circle, x times the whole, which is 23. Alright, so 7 times 7 is 140 plus 49, so 189. Right? Yeah, 189. And then I've got 23x over here. I just rearranged that to make it look a little more standard. Now I'm going to divide both sides by 23. Those cancel out or become 1. X equals whatever 189 divided by 23. Be nice to have a little calculator here at this point because it really doesn't go into that very nicely. Let's say about 8 times. Let me try that. 160 plus 24, 184. Ooh, that was nice and close. So I got 5 left over, so 8. And because it's in decimal, let me drop that down there. It looks like it's going to go in 2 more times. That's 46. I got 4 left over. You're going to get a little less than 2 out of that. So rounded, I would say it's 8.2, and that is it. All right. Outside times whole equals outside times whole. You just have to really, the critical thing is labeling the information they give you and making sure you understand what's outside and what's whole. Now let's take a look at another one that's very similar but has a little difference to it. They nicely labeled everything for me. So I've got, outside, I'm going to start with 14 there. Outside times whole. Now you might be thinking 52, but I want you to recognize that the whole thing is the 14 and the 52. So here I'm doing 14 times whatever 14 plus 52 is. Okay, so that's outside times whole. The other one is 13 times, that's the outside, and the whole is, just like over here, it's x plus 13. You might be saying, where'd you get that? Well, here's x is just this piece in here, but the 13 had to be added to it. So that's outside times whole. Now, I could do, over here I'm going to do distributive property because I can't really add x and 13, so I got 13x plus 169, that's 13 times 13. And then over here I've got, I could do distributive property, but I'd rather just add this 14 and 52 because they are like terms. I get 66, and I'm going to multiply that times 14. And that I can't, I probably could do it in my head, but I can't. I'm not going to on the fly like this. 24, 25 times 6, and 66 for, probably should, 924. Okay, I was not going to get that one. Alright, now we're going to just solve this for x. So we're going to minus 169, and we get 755. 13x, we're going to divide both sides by 13. 13 goes into, boy, it'd be nice to have a calculator, 755. 13 goes into this, so I'm going to say 6 times, 60, 70, nope, almost 6 times. 5 times that, that's 65. I got 10 left over, I'm going to drop that 5 down. 13 into 105 goes 8, 7, I'm going to say 7 times. No, should have been an 8, I guess. Yep, okay, so it should have been an 8, and the closest thing to that is 58.1. So, bottom line is outside times whole, the whole was made up of this little outside plus the inside part, so watch out for that one. Alright, I think this is the last one. It was, what's different about this one is we've got an outside component, but it's a tangent line, so it stops here. We're going to ignore this part. We're going to ignore the overlap after these lines cross, or these lines cross, and then we've got this part that's outside, and then of course the whole is the whole line there. And let's see what we got. So we're going to still do the outside times whole. They tell me they want to know BC. They want to know this. They give me BD. Make sure you understand what you're labeling here. BD is obviously the whole. So we got outside times whole, or that is x times 15, or 15x, equals, on the other one, outside and whole are really the same thing. So some people write it as outside squared. But it's outside and whole. We're ignoring this part right here. there was no inside part, so it's 10 times 10 or 100. And then we're just dividing by 15, and x equals 15 goes into that a little less than 7 times. I believe that's going to be, no, I'm not going to, 15, I know it's 6, I got 60 at 90 with 10, 10 left over. 15 doesn't go into that, I got to add the decimal and the 0. Again, it goes 6, so it's 6.6 repeating, so it is C, 6.7. Okay, a little bit confusing there with the outside times whole. We got to really label stuff and watch what you're looking for. Good luck with that.